Hi guys, sorry I've been away for a little bit. I've been busy doing some other stuff, helping helping some family with some remodeling work and stuff. Anyway, we're back. I'm going to be talking about a couple things in this video. One is this chassis I got here, which I'll zoom out. I already started working on it. And lock this thing down. Back. Anyway, this is a Philco model 377XX. Now the XX means just that it's a console cabinet. I'll show you the cabinet after a bit. It needs a little bit of attention, but not much. When I got this radio, there was a few blemishes, a couple rust spots on it and stuff, and plus these sockets here, the shields, the base part of the shields, were all chewed up because they put metal tubes in them, metal style, as opposed to what's supposed to be in there, which is the G. G has a smaller base that fits in. The metal is much larger, so the G won't fit. The metal won't fit in these, and they chewed them up. So I had to replace those. Well, I had it apart though. To do those, there was some issues underneath, and plus cleaning the chassis and everything, and I was going to paint the transformer. I had a little rust on it. So I decided just to go ahead and pull the thing apart. I'm in the process of putting it back together. Anyway, I wanted to show you one thing here is when you're trying to pop rivet these back in, and you don't have to use pop rivets except for like this one here is going to have a ground lead that goes through the hole. But otherwise, the rest of them you could actually use bolts if you wanted to. But if you're wanting to use pop rivets on them, the bad thing is the regular pop rivet gun just, it don't fit. So I had showed and talked about this on an earlier video of taking a spacer and putting a spacer in between here and using just a standard pin. And for the most part you can get by with that, but I swear I think the pins are getting shorter than what they used to be, because this thing has to be pretty much, it won't catch there, it just starts catching right there. So, and that's really just not quite enough to get it away from the side of this. Now, there's a couple ways of doing this. You can use a spacer like this. If you don't have anything like this, one thing I have found was, I wanted to use something longer, but, well, I probably could. But these are a little bit bigger rivet that I just dropped on the floor. But they will work as a spacer. Now, what's inside here to make a longer pin is nothing more than a 6-penny finish nail. Just like you would, go to the hardware store or lumberyard and pick up some nails. It'd be the same nail you'd use to nail your trim on inside your house, around the windows and doors. And it's plenty long enough with the spacer to get a hold of it. Now, one thing to realize, this is not the aluminum pin that's inside these rivets like this, which are designed to pop loose and break about right in here someplace. This is not going to break. So you can pull it all the way through, that's perfectly fine if the rivet is just about the right size for the hole. It'll do just fine. Or you can pull it so far and get this expanded out good where it feels tight, and then stop and then drive this back out. Either way, You can use something longer if you want, like another rivet or a spacer, but you can use rivets or spacers. As far as getting these out, getting the pins out, we'll stick it right there. And they just drive right out. Not a problem. And we'll just go ahead and use this one. The other thing too, something I wanted to point out, is when you do pop rivets, you know, the pin stays in. You can get rid of the pin if you want to leave a hole in there by just taking a punch, and it pops right out. Because they'll pop right back out just as easy as when I popped out that pin on the rivet. So in any case, you pop the pin out, maybe take a second rivet or get a little bigger rivet, whatever you use as a spacer. 6-penny nail works with these. These are 5/32 rivets, which seems to fit these holes pretty decently and gives a large enough hole in the center here for this cloth covered wire to go through for like your grid cap. That's what I got in here. It's not even fastened in, it's just there. So we stick that in a rivet gun and pull her down, get her worked into the hole, and it allows the rivet gun to sit pretty square. And we just pull, so it's a little loose, so we let her down a little more. And that's good. And we just drive the nail out. And hopefully not damage wiring. So, if you can see in there, yeah, it widens out the rivet, just pretty much the same. These are rivets that I didn't have to extend, and it just widens them out. Socket's nice and solid. Now, one thing I want to point out is if you strip a chassis completely down to clean it up, maybe it's got a lot of rust or something, or you want to do a lot of polishing or something. I use a buffing machine designed for buffing cars and stuff to polish these because I'm lazy and they're not expensive to buy. You can get little deals put on your drill too to do that. The biggest problem is you got to pretty much have a lot of stuff off the chassis top, like screws and everything else, and the stuff will get into the sockets real bad, so a lot of times I'll pull them too. But when you go start putting back like terminal strips, like in here and here and stuff, you pop rivet them. If you're bolting them, it's not quite as bad, but if you're pop riveting them, they generally may not be perfectly tight. I mean, they'll feel reasonably tight, but some of those have grounds connected right there. And if they do, the best thing to do is go ahead and do a little soldering too. Just solder those after you pop riveted them. That just guarantees that you got a good electrical connection. So I did like right down here on this. You can't really see it too well, but right in here on this one here I soldered it. Probably can kind of see that one there. So if they don't, like this one up here, see, nothing's connected to it, so you can just rivet it. You can bolt it if you want to, that's fine too. So anyway, I just got to start putting it back together, and I'll do some series of videos on this as I get further along and putting it back together. Now, let's see, something else I want to talk about. Now, I rebuilt the can capacitors already. Basically, I just cut it right here. This is the same terminal that they use for their negative. And what I did with that, it generally just fits by friction against the side here. It makes contact, and when the clamp's on, it would be tight. You probably can't see it, but down inside here, I drilled a little hole, and I brought my negative lead off the capacitor up and just wrapped around down the base and soldered it. So this is actually effectively truly soldered to that negative on the cap, instead of trying to get her fitted to the aluminum. They had chopped the pin off when someone had replaced this cap. The radio was pretty much original, except for a couple, about 3 or 4 things. One was a couple of filter caps had been replaced in the past, and when they did this one, they just, instead of unsoldering all the leads and everything that went to this, they just cut it. It was normal practice just to cut it and then tie it onto your new cap. What I used for that center post was some number gauge 12 wire that came out of a radio that I worked on in the past. This was added in for a external phono, and the radio actually didn't have one, or it didn't have a phonograph. So there was a couple of these, and it's 12 gauge is what it is. Now what this is a piece off a terminal strip. You know, the leg on the terminal strip where you connect onto. So basically one of these here. The reason why I have those I'll get to in a minute, but it works out that they fit reasonably tight on here on number 12 gauge wire, and then I just soldered it on good, and that gives me something to hook my new terminals to and stuff. So anyway, that bolts in right down in this area right in here. Now that brings me to why I had those terminal strip pieces. And if I bring these wires out, there's a 10 ohm resistor down here. Now a couple sections of it we're testing reasonably close. This end, let's see, yeah, this end tested right on the money. This one right here was way high, and if you moved the legs, the pins on here, then it would vary. And the reason why they do that is this has, what's inside these is just a phenolic board that fits in there, and these, then they wrap that with nichrome wire, resistance wire, the number of turns that they need to get the resistance that they need. Wherever they need to have the lugs, they just crimp those on. And they're not like really hardened steel or anything like that, where once you crimp it, it's never going to move. They're pretty soft, mild steel. And over time, and you know, it is a power resistor, so over time, in certain sections of it heats up and cools down and everything. It expands, contracts, and eventually it opens that up so it's not making as good a contact. So what normally you will find is they might test reasonably okay, or at least give a reading, but if you move where your leads are connected on any one of these pins, move back and forth, you'll see your meter move. And it can fluctuate quite a bit. This one in here in the center is supposed to have been 8 ohms, I think, or 8.2 ohms or something like that. 8 ohms, I think it was. And it was moving like, I could get it sometimes in certain positions as high as over 10K, and sometimes drop down. It never dropped down to 8. It dropped down to like maybe 100 ohms or something. So I kept thinking about what I wanted to do with that, and so I finally decided to just remove it, and found out that the case on this one was actually fairly mild steel. Now some of them are a little bit tougher to open up, but this one was reasonably easy to open up, and I opened it up and I got the old out, got the pins off. I took a new terminal strip. It was a 5-pin terminal strip, and I took all the pieces off it, all the terminals off. That gave me a nice little phenolic, and then I put these pins back on, crimped them on there, and then got me some resistors and soldered them on. Now these two sections here is a half watt is more than enough for those, so that those were easy. Up here is a 202 ohm resistor, and it works out to be just around a watt of actual dissipation, wattage burn off. And so I didn't have a reasonable size in physical size 2 watt 200 ohm or something around that range, but I did have two 100 ohm 2 watts that were the small, fairly small size. If I had one of them in say 200 ohms and I didn't feel like ordering just that, I could have. It would have, this side here, this end would have went down a little easier. I'm hoping you can see that real good, because I got two in series in here, and that's why this is opened up more than what these two ends are. You can get these at Mauser, and they're pretty small. They're about the size of a half watt, but they're actually a 2 watt resistor. Anyway, then I put heat shrink tubing around it, and then crimped her back closed. It's reasonably tight. So now I've got the resistances I'm wanting to have. Now instead of 8 ohms, I got a 10 ohm here. This one's supposed to be 35. I got 33. So the overall, and this is 200 instead of 202. But it's plenty close enough that it'll be fine. Now there's another interesting thing about this. Like I said, this can here would fit, well, drop my pointer off, and it would fit in like so. And so that ground pin, or negative, is better. See, this is floating because we've got the bias here, and bias resistor. So that negative hooks right here. That's this capacitor right here. Negative hooks here. We got the center tap off the transformer hooking here, and then it comes over and hooks to the one end of the can ohm, which is right here. Now if you notice, the other end of the can ohm goes to ground, so that we develop the current going through here, we end up developing negative voltages. Well, the way they did that, the factory had done that originally, or the way they did it at the factory here at Philco, was they went ahead and soldered right to the can and soldered up to the pin on that end. And of course, once it was riveted in place, you had your ground. Alright, that's all fine, Danny. Plus you had one more wire which comes across. Well, actually it didn't have a wire. It came up, went to 1 meg, and right to the output tube. Well, this is the output tube here, and a 1 meg resistor set right in here. So it went from this negative pin to right here to the grid of the 6F6. So there's a 1 meg resistor here, hooks to the negative pin on the cap, and then we had a wire connected here, and we had center tap coming from the transformer hooked here. So we had all of our connections made up for this end to be what it should be. The interesting thing was, when I started tearing into this radio, I found another connection from this negative, an extra wire. Wasn't like the wiring that was in here. It was a little different, a little smaller diameter, physical diameter. So I traced it out, and it went over to this point right here. There's not supposed to be anything connected to that point at all. Bob over at B. Anderson TV does a couple videos, or does a video on this on his share side, which uses the same chassis, the 38.7 CS, I think it is. Anyway, it uses the same chassis, And you'll see in a couple of his videos, and he has you'll see that cap, and there's absolutely nothing on that pin. It's completely clean. There never was solder on it. And in fact, he has a parts chassis, and he showing it and everything, and you actually see also on it in one point on the video where it don't have anything. There's not supposed to be anything connected. Now there's connected on this side, but not this side. This goes right to ground. They brought that wire down to here, and I'm going to show you the pictures here in a minute, and that connected to this, the negative. Effectively what they were doing was they were connecting a ground right here. So we took the center tap to ground, we took this end of this cap to ground, but more importantly we took this to ground and took the grid, pulled it to ground instead of negative voltage. This shut this off. No more current went through it. So those bias resistors, that can ohm, had no current going through it, so no negative voltage being created. There's no way the radio could have worked worth a crap. Now the interesting thing is, this resistor, when I went and started taking this thing apart, it fell apart in my hand. And there's a reason why it did. At 1 meg, pulled to ground with no cathode or other type of self-biasing, this thing had to try to act as grid leak. 1 meg is way too small for grid leak. So, and generally you don't do a 6F6 or a power tube in grid leak anyway. This would have probably developed a bias of somewhere maybe negative 1 volt or less, or it might even been closer to 0 volts, which meant that on the positive half cycle of any signal coming through, this tube was conducting on the grid, which this resistor went to ground after they put that wire in. It overheated that resistor. The other problem is this tube, the first audio might have worked alright since it's just triode and it's got a couple megs in it. But the other point is we're developing the preset negative voltages for the IF and the 6A8 detector tube for their grids, which is around -3 volts is what they're looking for with no signal. Well, we didn't have that anymore. The other thing is, we come up here, since we're using a triode for a detector 6J5, this comes up and supplies a negative to the plate. So that the grid to plate here becomes one diode for the ABC, and then grid to cathode is the other diode for the signal. This would have been floating basically, or right around ground. It could even effectively shut off the entire tube as it being a detector. In any case, we wouldn't have had much signal coming through here because they would have been pulled to basically 0 volts on their grids. The first audio might have worked. The output tube, whatever sound might have been coming out, have been extremely distorted and very weak. Do not know why we put that wire in there, but it was a big mistake, or who did it. Like I said, this cap and this cap was replaced, but I think at different times by different people, because this one was replaced properly by cutting the old one out, taking it out of the circuit. This one was replaced, but they left it in. They just paralleled it with a new cap. Whoever did this, I don't know. I don't think they would have done this when this was done. It might have been done later. I have no idea. One last little thing that was done to this radio is this IF here appears to have been replaced, or at least pulled out. Way I know that is the different connections, except for one, all the connections on here, all the wires coming out of this had been cut and then resoldered, and they left a short pigtail there so they knew where the colors were, where the wires should have went back. So they'd cut them, left about a ½ inch piece there, and it just stayed there, and then they wired it back in. The interesting thing is, and I believe it's either this grid wire here, the green, or the white. I don't remember which one it was, but there was a long extension added to it. Like it just wasn't long enough to reach. Now I don't know why we would have cut out an entire wire or a piece of wire when it was taken out or anything. So I'm thinking that this was replaced with another used IF, which checks fine and everything. And since it was used, whoever cut it out of the other parts chassis, that wire was cut a little short and they didn't have enough, so they had to add on. Other than that, basically not much else was done to the radio. Now I said I'd show you a picture of this little incident here. Show you that wire, and I'll see if we can get that pulled up on the screen here. Bear with me. We're going to go for a little bit of a ride. Okay. Sorry. Let's turn in just a hair more. Okay. See if I can kind of zoom in just a little bit. Now, here's that wire. It's coming here. There's that resistor there. This here is it right here. You see the resistor just opened up on the end. That was hooked to the tube. That's that 1 meg, and it's hooked to this wire. This is not the same type of wire it's used in the radio. This has cloth underneath and cloth on top. The wires used in the radio are basically a rubber, kind of rubber-like material underneath the cloth. So they're a little different, a little later. This is older style wire. But that was this wire here. There's that pin right here, or yeah, right here on the negative of the tube. Alright, the capacitor. There's that resistor going over and connecting to the grid. Comes across here. There's a little short wire here going to that post on the grid resistor, the negative resistor divider right here. And right there is the wire comes back over here, goes to the center tap of the transformer. Here's a replacement cap that they put in, the negative of it hooked here. But they hooked that wire to this mess, brought it over, and hooked it right here. And that comes down and goes here. I don't know if I can. Yeah. See, that comes down, goes to here to the bolt, bolts to the chassis. That is ground. So, I have no idea why they did that, but that's what they did. Now this here's that piece that I told you they cut off of the anode, the positive right here. And there's the, I already cut this. There's the remains of the positive hooked to it. So, strange things. Sometimes you run into some weird stuff. There is no way this radio worked after that fact. It wouldn't have worked. So anyway, I'm gonna stop the video here, and we're going to talk about the cone-centric mechanism on this radio. This is a cone-centric tuning radio. So we'll talk about it. I've got it tore apart and been cleaning it up, everything. So when I come back to the video, just in an instant, I'll have it up on the bench. Alright guys, back. Here's the, let me clean the knobs one more. The cone-centric all tore apart. Now don't let it bother you that these cones are all in one spot, because that's basically the way they were when I got the radio. It doesn't make too much difference anyway, because I think about half the presets are like don't exist anymore for this area, and it was for around this area basically. The rest of them are, all of them have changed frequency. So, but Yeah, I'll kind of set them anyway once I get it back together and working. So how's this thing all go together? I don't know. I tore it apart. I don't know how to put it back together. So no, seriously. Basically, this part here sits on here, and it can only go on one way, and it can only go in one place. You've got these little points here, and you've got these little guys here. Allows placement only in one way, and then you just screw it down. Okay. Then this part here, which holds the dial, that's inside here, and of course you got the dial light. It goes on like so, and it can only go in one place. In fact, the only adjustment for the pointer throughout this entire operation is when it connects onto the tuning condenser. When this whole unit connects to the tuning condenser, that's the only place that you have any adjustment, because all the different pieces that connect to the shaft, one shaft, you notice the shaft is, alright, got a, kind of like a cut off spot here, so it's keyed. This is your main concentric that you, or the main piece that you turn and move. And see, that only goes in one way. Okay, the pointer, which I've got in a drawer, it is keyed to go in one way. And of course, all these pieces bolt down and keyed in one way. This is your counterweight on one side, which goes again onto the back side of this, is keyed in one way. So this side is what connects to the tuning condenser, and it has two screws because it's not keyed. And let's see, there's no key. So when you're setting the pointer, you're setting it by loosening these guys up, taking the, in fact it tells you that you take it with the condenser completely closed, lowest frequency, highest amount of capacitance, and it'll show that the pointer should be just to the side of this little dot. I think it says like a 1/16 or an 1/8 of an inch or something, just basically the width of the pointer away from that dot. And then that is at the lowest, that's with the lowest frequency, that's with the highest capacitance tuner, the tuning condenser completely closed. So now, if you watched other videos like Bob Anderson's video, you've seen a wire coming out of here and a little thing here. Well, the little thing here was the detent. It fits onto this shaft, and yes, there is a break in the shaft right here. That's insulation material. The rest of the shaft's brass. You notice the bottom side is steel. So what basically would be holding them together is this part. And the shaft goes in like this. I'm not going to put it in quite yet because I want to lube it up. It goes in and operates against this switch or this switch. This switch here, which has a wire coming down to here, connects to this. This switch here rides against this plate, which is insulated. It's got phenolic. This is insulated from here. That is connected to a wire, which then in turn goes out. It connects to the volume control on the center pin of the volume control, the wiper. And so when the switches are all working, they're either grounding out that, taking it to ground, or it's open then, and the switch is open, so then they're not to ground, you hear the radio. The thing about these, and what makes them sometimes possibly, besides, well, and it actually boils down to dirt, but can make them, even when they're probably working dead perfectly, still not be quite perfect, is how they get ground. They get ground from moving parts. Ground comes from this point here. This through this switch and through the switches in here goes to ground. That grounds it to this point, which in turn takes it to the shaft, and this point, which then is bolted solid here, which then is bolted to the chassis. So your ground is going through moving points. So as you're rotating this around, if it does break ground, that's just going to be something that's going to happen. If they'd have cut this down just a little bit, milled it a little more, it's got a little looseness in it, but not much. If it had a little more in it, they could have used a brass or copper washer in there that they call wave washers. They're kind of wavy. They're not completely flat. And what that would have done was kept some tension on it and would have kept good contact. I'm hoping with some lube, such as Vaseline or something like that, which conducts electricity. Vaseline is a good lube for when you're working with something that you want to conduct electricity through it and still lube it. I'm hoping that with it all cleaned up and everything else, that if it does break at times when it's moving, it won't be extremely bad. It'll just be very limited. But that's the reason why they would break. Now, as far as I've seen other issues, these cones do have a little bit of play in them. So if you get one where maybe, as long as it's all factory. Now if you start mix matching pieces, I doubt these were made in a factory with an exacting tolerances. So if you take a back plate and connect it to a different one of these, it may be off a little bit. You know, the difference doesn't have to be much. But if you got one that you know is all factory, all the pieces fit, and some of the cones it's not operating right with, try loosening the cone up, moving it over, and then retightening it. Because they do have a little bit of play in them. I don't know if you can hear that. So you might try that and see if that helps. I made my own little wrench. Somewhere I've got an actual bit, and I have, for the life of me, don't know where it's at. These used to be extremely popular style set screws back in the day, up into the 60s even, 60s and 70s. So for some odd reason, I managed to misplace the bit that I had. In fact, I should have had two. Anyway, so let's see about what goes inside here and here. This part here, the detent, and I'm moving around fast, I'm sorry about that, is just simply a spring. We got a screw with a lock nut so you can get it set to the right tension, more or less by feel. And then we've got this little piece here, which is kind of a half ball here with a sleeve, so that it rubs nicely when it's lubed and everything. See, that would be making your contacts with your detent here and detents down here. So this here, I believe why they put that in there, because the detent don't go in there. I think that's just the storage for lube. Now the switch is just a simple little ball that's sleeve and ball that they solder on. Then you got the insulator and a spring, and again it fits through another screw with a spring here. Fits through another screw with a lock nut to get the proper tension. That would go into here, and voila, there you are. And then that wire there actually hooks, no, hooks to this point here. So that they're in series, basically is what they are. Either this breaks ground by use of this unique little device. See, when it's up next to a cone, it pushes it just right so that it's, when you start pushing down on the shaft, it'll push it in because it slides down the cone. It goes like this. If it's not against a cone, it goes like that and misses. Hope you see that. It misses. Up next to a cone, it pushes it over. When you start sliding it down, it keeps pushing over, and then that breaks contact. So, with two switches in series, either one of them opens or breaks contact with ground, or opens up, then ground's broken. Alright, so we want to lube this up. We're going to use a little Vaseline on it. So we'll make sure I get that covered in good there, because that's our little device. And I don't care if we go up this way a little bit, because remember, if you've seen any videos of this, it's got two knobs on it. One fits up here, the other one is your slide knob. It's got a spring, it slides down, and what fastens onto this is this little knurled, with the glass in it, this little knurl. Well, that's for your fine tuning when you're just doing manual tuning. Now, I had rubber on the back that was shot. I happen to have a rubber O-ring that's virtually the same size. Took a little contact cement and glued it on. So, but anyway, I want this lubed up here and this lubed here because this little knob rotates on there. So that as you're moving around, it rotates. So, well, a little lube everywhere. So that's fine. And lube down in the bottom down here. It won't hurt nothing to have a little too much. This stuff is not going to kill anything. Now, I know I said it conducts, and I'm going across this. It only conducts with really solid contact. It's not like it's got high resistance if you're just going across that bay there. It will not hurt it. Now, this only goes in one way. It cannot and will not go in this way, because this end is bigger than up here. And then this part, this brass part. So it just slides in like so. And I'll wipe some of that off. Wipe my fingers off. Now, if you want to get one of these out, you just kind of got to shove this back in like that to keep it from hitting. Shove it back like that so it doesn't hit. Otherwise, it's going to hit. So, now, there's no ifs, ands, or any type of instructions about what the tension should be on these parts. So you just kind of go by feel. We're going to put in the little spring detent first. I want to add just a little bit of something on here just to keep it together when I'm putting it in the hole. Nice thing about grease, it acts as also something that sticks to things. So we'll stick this in like so. I'm going to move that. Okay, in the lowest part of the detent. Now we're going to stick our little set screw in. Move the nut back just a little bit. And we stick this in here. And get it started. Be nice to hold it straight. Time you're trying to start a screw against a spring, sometimes it's not the easiest thing. We're going to tighten it just a smidgen down, and we're going to just go by feel. And I want a little tighter than that. I'll tighten her a little more. We got plenty of room to tighten. Them springs are pretty. Yeah, it feels pretty good. So I may adjust it again later. Now to do these adjustments, a lock nut, you put your wrench on there, and you take a screwdriver, and hope you can see that. Now hold your screw until it's tight. That way your screw don't turn. So anyway, first part, yeah, that's nice. Now again, we're going to kind of lube this guy just a little bit. Lube is good. Now this just sticks right in here. And we'll tighten her nut down. Good spring tension on it. There we go. Now feels good. So we're going to tighten this nut down. Now this one here, the screw don't generally move too much, so I can tighten it pretty good without it moving. That takes care of that part of it. And bear with me here, I got to get a rag. My hands are a little greasy now. So I was going to use lithium grease on the rest of it, but I decided that it'd be best not to. Since ground is going through a moving shaft, that's how it's picking up ground. I want something that is designed to kind of conduct that electricity with movement. So back when I was a kid, I had a Lionel train. It was one of those, the 3 tracks. The center track was the hot one that supplied the voltage. Every once in a while, you know, that'd get a little dirty and dry and sometimes not make good contact. And my dad taught me that you just take petroleum jelly, Vaseline, put along on that track and also on the runner underneath the slide. Worked perfect. Alright, so this goes in here like so, and then we'll lube it up and we'll run the shaft in. So take this. I'll worry about soldering this wire down after a bit. I don't have the soldering iron on or heated up. I just want to show you guys how this thing comes apart and goes together, at least to a certain extent. So just lubing everything up. Stick it in there and stick our shaft in and try to hold 3 things at once. There we go. Right about there. Looks pretty close. I may have to make some fine adjustments to this, but Now we just take this and tighten it down. There we go. And see, that'll just solder right on. Okay, now and I just put it in upside down. Why didn't you guys stop me? Probably did. Yeah, because it can't go that way. So, no big deal. They come apart. Easy enough. Back it off. Yes, try getting it out when it's lubed. There we go. Now just getting the line back up. There we go. All right there. Oh, too much. Okay, now, there we go. Now the plate comes over here, and this will go on like so. And little guy goes right there, I believe, if memory serves. And here's one other thing I need here that I don't seem to have. There's some lock washers. So that's not a problem. Okay, we're good to go. We're lined up. It appears to have a small washer underneath. And this one on there. These line up here. These little pieces here are just to hold the wire down. So we put all these screws in. And tighten them down. Seemingly this did have a weird one. I think that's actually the washer is supposed to go there, but I don't seem to have it. I'll find it later. It'll work. Nonetheless, now we'll just tighten those down. And yeah. hold that and hang that down. So now that's on there. Now we're just going to put a light dusting here, which will keep this from corroding anyway. Vaseline onto this. And I'm just going to show you where else, what else goes on and how it goes, the basics. But I'm not going to get carried away with it because I need to solder that wire. And once this piece goes on here, because it basically goes on like this, it's a little more difficult to get in and to get that wire. And you just screw it down, same basic screws and washers. And then once that's on, the wire feeds out of that light through here and comes down this way. There's another wire that comes up and hooks here. That'll go to the volume control. As far as the knobs go, this would go on as such, and then this would go on like so, which popped right off with the spring. This one then goes on to hold it on. Oh yeah. So anyway, put the spring on, knob goes on. That's after everything else is on. And then this goes on, and then this holds it all together. And we just, when you get to a thing, you just shove it down, it's locked. So, like I said, this will go on here, and after I take the knobs back off. And then what goes, and then the dial goes inside, go inside into here, into this ridge. The dial fits in, just like so. And then there's a locking collar that just locks down underneath these little grooves here, just spring steel, and fits in there. And then this, there's I gotta clean the glass on it yet. There's little pins right there's one, there's another one, and somewhere over here is one. Those lock into these little slots here, so it slides on, rotate, and it locks on. And that's basically all there is to it. That's about all I have. And of course, on the back side of this will go on here after I get the wires hooked on, and it fits down on, and then you lock it in place, and that gives the counterweight for this thing. This thing's quite heavy, so, and so is this, so it's opposing this. It's off to one side of that. If you look, you see it's off to one side, and that allows it just to stay wherever you put it. And then the whole works will bolt onto the radio, 4 bolts here. There's 2 braces that come down from the back, comes down the chassis to hold the top, and of course this in turn slides on the tuning condenser, which I cannot put on the radio yet. I'm waiting for my rubber parts to come. I just ordered them just Friday, so it'll probably be sometime middle of this week to get those. The chassis had well, the tuning condenser rubber pieces, feet that it fit on were rock hard. The chassis has 4 corner pieces. They're not rock hard, but they are deteriorating. Here's one here. They are flexible, but if you notice, they're starting to fail. And I think they're kind of shrunk down a little bit. to me, when I had them on there and I was sitting on flat on the surface here, it barely had any room between the bottom of the chassis and the tabletop. And then there's 4 little rubber pieces that goes inside where the bolts go up through in the chassis, and to hold it down, so those bolts will float some, and of course everything's floating, so that the tuning condenser does not have any problems. Speaker in it was in fine condition other than cleaning. Here's the speaker, so it really is nice shape. Sets in like this. They get dust covers on this side, and then a plug that plugs in right here. Audio output transformer. I already checked all the resistances. They check good, so the speakers should be perfectly fine. Ready to go. Give me a second and we'll take a gander at the cabinet. I'll be right back. Alright, I'm back. There's the cabinet. It's got, thing about these, and it was a big selling point, it had the slant right here, so you didn't have to squat down or anything to tune the radio. So, but this upper part of the cabinet, the grill cloth is dirty, but seems to be in fine shape. There's scratches, and you know, she's got some wear on the cabinet. There's little bumps and nicks and things, but I think I'll probably just do a Howard's Restore on it. There's one little spot right up here on top that I think will clean off. So anyway, a couple of issues with the cabinet really is right in here. You can see the dirt behind it. I have to clean it. But this little piece here, I'm going to have to get it cleaned out and glued so that get it glued back on, or back up the way it's supposed to be. The other issue is in the back here. Hopefully you can see that. So, sorry about shaking, but we've got, it was a little loose there, so that'll need to be glued. Inside, it's a little dirty. I haven't cleaned it yet. I have the bolts setting in here. There's rubber in there, but they're rock hard. And Renovated Radios is where I'm getting all the rubber parts. They're real reasonable, and they've got them. There's little rubber pieces that go in here. They had those. I think I paid total for those four, the 4 feet rubber pieces that goes on the corner of the chassis, and the rubber pieces for the tuning condenser. I think it's like 21 bucks or something. It wasn't bad. Wasn't bad at all. So anyway, and you know, these radios have different production runs. The nice thing about this radio, I know exactly which one it is, and I don't know if you'll be able to see it, but there's run number, and it's a very faint 2. So this is production run number 2. It's nice to have that label still in there. The other labeling, which is the tube chart, is still in here and in good shape. The other thing about this, other than I think the face, the slant face, and that one piece I showed where the veneer's coming off of, is the only places that really have veneer. The rest of this is actual wood, or well, the veneer is wood, but I mean, it's actually solid wood. It appears never to be veneered. So this wood, this instead of being plywood with a veneer on it, is a solid chunk of wood on both sides as well as the top. So this cabinet is quite heavy, and I think that's just the natural state of the wood inside here. So I think it's walnut. If you notice the clips, see if I can, yeah, okay. Right here, these are what hold the back on, and I don't have the back. But I have a picture of it, so a decent picture. It was on, I think, the Antique Radio Forum. So I'm gonna, since I got a good picture, get some like masonite material or something, and make a back for it when I get done with it completely. So anyway, that's about all I have on this. Oh, one other thing. I didn't only get this radio, and actually surprisingly it was in this town. I got something else. Don't mind me. Generally, where I live is not a very good place to get stuff. In fact, the state's kind of dry. I got this with it. It's got a little crank on the side, right there, that you rotate. And if I can get this open with one hand. Okay, hold on a second. I'm going to put the camera down. There we go. It is a telephone. If I can get the phone out. This is, the cord's a little bit to be desired. If I can kind of move it back here. But yeah, that's the phone. This is how you would transmit. The switch right here rotates when you was talking on it. And these little wires here connect right to these terminals here. They also came with ones that had plugs on them that would plug in. This here's how you hang it up. That's your hang up switch. Down inside here, I don't know if you can see it. Let me get my light. That's the batteries it ran on. 2D batteries. So it's 3 volts. Now what the crank's for, these have a bell. And they hooked the service battery here on that line, and then you had your 2 lines that went out to the other phones or to the switchboard. And when you rotated this sent out about 100 volts. This is just a little magneto generator, and when you turn it, it would send out about 100 volts, and that would ring the bell either at the switch operator or at another phone, and they'd pick up, and as soon as they pick up off the receiver up, they were on talking to you. This is from, yeah, just drop it. Good thing in Bakelite, really heavy gauge Bakelite. This is Signal Core EE8, I believe. This one actually dates from the serial number on it from 1937. They used these in World War II. At which time they switched, or at least in the Pacific Theater, they switched from the leather to a canvas bag, because over there the leather just didn't, in that moist air, didn't stand up. These were used clear up into the Vietnam era until like at least 67. But this one's from 1937. This is one of the first ones that the military bought and procured. So I said the cord needs to be replaced. Of course, it's just something to clean up and then set on the shelf, and you know, because unless you have another one, there's not much you're going to do with it. So it's not like you can hook it up to your regular phone service. It doesn't have this same type of signal. So anyway, I got this and the 387XX. Again, the XX just means that it's a console. All for $50, the 2 of them. So I didn't think I did too bad. on that. So anyway, look for more videos on the radio. I might do a video on this as a separate entity. The next video coming up after I upload this will be tomorrow. I'll be doing it. And the newbies, guys, pay attention. You want to watch that video, because we're going to talk about phantom voltages and what they are and how they can really throw you for a loop, and you know, cause you to, it could even cause you to have make mistakes and stuff. So that'll be on tomorrow's video, so be looking forward to it. So until then, guys, thanks for watching. If you like videos on both theory and restoration, and you know, of old tube equipment and stuff, and looking at this stuff, you know, and you're new to my channel, please subscribe. If you like this video, give it a big thumbs up, and feel free to comment if you have any questions. I will get back to them, and I'll either answer them on the comments or I'll make an answer video. So anyway, until the next time, thanks for watching, and I'll see you on the next video.